Нэг цагтлын тухайд гэх юм бол таны одоо баг хамгийн туршлагаас нь ингээд асуух гэх юм бол манай гэр бүлийн тухайд нэг юм Ковид-19 цар тахалтай холбоотойгоор юм уу?
Ингээд судлаа хийсэн гэж хэлсэн. Яг үүндээ бол нэлээд авсан нэг одоо уушгад явуулж чадаад байна. Яг 7 сараас эхлэх projekт одоо бүтэн ажиллаж байсан. Бидний 7 сар ихээр хөлөндөөсөө тэр нэлээд өндөрсөн час эцэгтэй ийшээс багцсан зүйлээ шоутай нийлүүлээс гэхдээ Монгол шаттай нэг шаардлагатай тавхад гэн тэр одоо олж гэсэн тийм нэг бодлоо. Бидний Батын Их Сургуулийн самба буюу статистик ба хэрэглээний математикийн докторийн сургалтын төвлөрч байдаг. Биднийхтэй хамт судлаачид байгаа. Нэгдүгээр Монголын талаас 3 асуудал орсон юм. Тэрний нэг нь бол энэ Монголд гарч байгаа Ковид-19-ийн гаргалтыг загварчлах гэсэн юм.
Building predictive models for COVID-19 is important for all countries, not just Mongolia, since we're seeing quite a large spread in infection still, with many cases on the rise in many countries. So it's really important that we try to use our models to help inform control policies, such as social distancing, mask wearing, maybe when we want to close schools or workplaces. And this can also aid in public health planning, for example, in predicting when health facilities might be overburdened.
One of the most basic mathematical models that we use, or this was developed back in the 1920s, so it's almost 100 years old now. It's called an SIR model. There are 3 parameters in the most basic SIR model. There's the transmissibility, how quickly do when infected people meet up with susceptible people, how easy is it for them to pass the disease between them. Then there's the recovery rate, which is how quickly people recover once they've got the disease, but it's the size of the population. It makes a difference in the model. The bigger your population is, the bigger your reproduction number is.
I'm interested in how aspects of such as spatial separation and demography, for example, age of individuals in the population, affects the transmission process of an infectious disease.
Winter naturally, usually meaning higher transmission of respiratory type viruses. When people tend to be colder, people tend to be congregating indoors more. The more time you spend in a confined space with very little airflow, the more chance there is for this, these micro droplets of virus to accumulate in the air. And it's very important to actually understand the underlying kind of aerosol dynamics. This is where computational fluid dynamics comes in, because there's a kind of a natural airflow in the space, then the kind of the virus which is sitting in the air kind of gets brought along, along the path of the airflow. So it's very important to understand these dynamics.
One of the things that guides so much of our daily lives is actually from some very deep mathematics, right?
Yeah, so then at that point you can kind of compare with like what you see in reality. Does it match with what you are observing in the real world? If it doesn't, then you kind of need to like cycle back through that process. You need to, okay, well, maybe one of my assumptions was wrong. Okay, well, maybe one of the crucial one of the features which I thought was irrelevant is actually quite crucial. And then you just begin the modelling process again.
The problem is with surveys is there often is a very well-known gap between people's attitudes, people's awareness, and what they actually go on to do.
I guess that the world of policy setting is, I would say, more complex than the world of data science, possibly. Would you agree?
Yes, absolutely. I mean, there's, policymakers have choices and a whole range of actions and only the data science is one of the things that they will consider, as well as all other sorts of evidence.